Hey, welcome. Today we're going to climb what I like to call the AI ladder. We're going to see exactly how machines, from the really simple ones to the super complex, actually make decisions. And it all starts with a pretty simple question.
So let me ask you this. Is your thermostat as smart as a self-driving car? I mean, think about it. They both make decisions, right? But the answer to that question really gets to the heart of what we're talking about today.
Because on the surface, sure, you could call them both AI. They both sense what's happening around them, and then they do something. But the way they think, well, their internal logic is just worlds apart. And that's exactly what we're going to break down.
So here's our game plan. We're going to climb this ladder of AI intelligence. We'll start at the very bottom with the simplest reflex-based AIs. Then we'll move up to AIs that actually have a memory. Then to ones that can plan ahead with goals. And finally, we'll get to the top, the ones that learn and optimize all by themselves.
All right, let's step onto the first rung of the ladder. This is the most basic form of AI, the reflex agent. Its entire existence is right here, in the present moment.
A simple reflex agent basically lives by one rule: see something, do something. It only cares about what it can sense right now, what the experts call a percept, and it completely totally ignores everything that's happened in the past. There is no history. And this pretty much sums up its entire thought process. The whole thing is just a simple if-then rule, like for our thermostat. If the temperature drops below 20 degrees, then turn on the heater. That's it. It's a pre-programmed reaction to a specific situation. It works, but man, is it limited. And here's the huge catch. This kind of agent only works if it can see absolutely everything it needs to know right now. If any part of the world is hidden, well, it's completely flying blind. It has zero memory to help fill in the blanks.
You know, that very problem, that massive limitation, is what leads us directly to the next step up the ladder. It's time to give our AI a memory. This is the huge upgrade that lets it deal with a world it can't always see.
This brings us to what's called a model-based reflex agent, and its game-changing feature is that it keeps an internal state. Just think of it like a mental model or a memory of how the world works. It takes what it sees now, combines it with what it remembers, and makes a way smarter decision.
Okay, so let's see how this actually plays out in the real world, because this is where it gets interesting. Picture an autonomous car just cruising down the highway. Suddenly, it sees the brake lights on the car right in front of it light up.
And then, maybe our AI car changes lanes a bit, and that other car disappears right into its blind spot. So what happens now? Well, it completely depends on which kind of AI is behind the wheel.
So a simple reflex agent would basically go, "What car? I don't see a car anymore," because its entire reality is just what it sees this very second. But the model-based agent, it checks its internal memory and knows, hey, that car is still there, even if I can't see it. I better keep a safe distance. That memory, right there, makes all the difference in the world.
Okay, so we've gone from just basic reflexes to having a memory. The next massive leap is to stop just reacting to what's happening and start actively planning for the future. And this brings us to goal-based agents.
A goal-based agent doesn't just know what the world is like now. It knows what it wants the world to look like. It has a goal. So it uses these cool techniques like search and planning to think ahead, to look at different possible futures, and figure out which actions will get it to where it wants to be.
And the huge win here is flexibility. Instead of having to reprogram a bunch of if-then rules, you just give the agent a new goal. When you tell your GPS to go to the airport instead of the office, it doesn't need a whole new software update, right? It just recalculates the best plan to get to that new goal. It's just a much smarter way to do things.
And now, we've made it to the top of our ladder. This is where modern AI and machine learning really start to blow your mind. This is where agents go from just following a plan to actually making the plan better. So, look, getting to the goal is great, but what if there are 10 different ways to get there? A utility-based agent adds another layer of intelligence. It doesn't just want to get to the goal, it wants to find the best way there. It has this thing called a utility function that kind of measures happiness or efficiency, and it picks the route that's not just going to work, but is also the fastest or the safest or the cheapest.
And finally, at the very top, we have the learning agent. This is the pinnacle, really. You can drop this agent into a brand new situation it's never seen before, and through pure trial and error, it will get better and better and better over time. It literally improves with experience.
And the way it learns is through this constant feedback loop. So first, its performance element goes out and does something in the world. Then, a part called the critic watches and gives feedback on how it did. Based on that feedback, the learning element tweaks the agent's strategy.
And then a problem generator suggests new, weird things to try just to get more experience. It's just this endless cycle of act, get feedback, improve, repeat.
So let's just put it all together real quick. You've got the simple reflex agent, like your thermostat, just following its if-then rules. Then the model-based agent, like an autonomous car, remembering what's in its blind spot. Then the goal-based agent, like your GPS, planning the best route. The utility-based agent, like a ride-sharing app optimizing for the best price. And finally, the learning agent, like an AI opponent in a video game that just keeps getting harder to beat. Each step up is a huge leap in power.
So there you have it. We've climbed the whole ladder. We started with the absolute simplest logic you can imagine, and we built all the way up, adding memory, then the ability to plan, then a sense of what's best, and finally the power to learn all on its own. Every single rung unlocks a completely new level of intelligence.
But that leaves us with a really fascinating thought, right? The top of this ladder, it's not finished. It's still being built as we speak. So the big question is, what comes next? What new, incredible rungs of intelligence are we going to see AI climb to in our own lifetimes?